All right. So we left off last class. I feel bad already. So. We kind of left off talking about elasticity, or price elasticity of demand to be more specific, and kind of talked about this was going to be a measure of the responsiveness of consumers to price changes. And we weren't just going to be concerned with units, right? We were concerned with percentages because $1 increase for a pack of gum is way different than $1 increase on the price of a car, right? So we said we'll measure things with percentage change. Right? Percentage change in quantity demanded as a response to the percentage change in price. We kind of said the denominator here is always going to be what is changing, right? What's the initial change? The price is changing. And then the numerator is, well, what is responding to that change? Here, demand, quantity demand, what was responding to that change. We said it's always going to be negative because the demand curve tells us price and quantity demanded move in opposite directions. This is kind of where we left off. So one problem is it depends on what, think about percent changes and how they could depend on what direction I go. So let's say I was going from $1, $2 in price. What was the percentage change in the price then? Yeah, it actually doubled. So that's a 100% increase in the price. But, you know, I can imagine like there is a demand curve and I'm moving from a price of $1, $2, there's going to be some quantity demanded at each one of those prices. So I'm really on this portion of my demand curve, right? I'm moving from $1 to $2. Well, the problem is, what if I move from $2 to $1? It's the same movement on my demand curve. What if I go from $2 to $1? What percent change in price was that? -50, right? So we've got an issue, right? And it depends on where I start, right? It depends on the direction of where I'm moving, right? If I'm going up or down, but even if it's between the same two values. So the method we're going to use to kind of resolve this in practice, like you could do some fancier math stuff if you had non-linear lines. But for us, what we're going to do is we're going to use this midpoint method. Okay, so I kind of have other examples here. I thought $1 and $2 easier to think of those numbers and really make the point of how different the percentage changes would be. Right? The same would apply if I'm moving between 80 and 100 or $180. So we got an issue, right? So what we're going to do is use this midpoint method. And the way that we do this is we look at what the change in that quantity demanded is, right? Or the movement between whatever these two values are, and then divide it by the average of these two values. Same kind of thing for the percentage change in price. How we're going to compute that. So I'll break this down here. So that percentage change in price, what we're going to do is take the new price minus the old price, and then I'll kind of use this triangle to represent that as a change. So the percentage change in price is just the difference in the prices divided by the average price between those two. So we'll look at the change in the price divided by, actually here, let me just write this out. The average of those two prices. So here, what was my change in the price? I was going from $1 to $2. So guess here, 1 to 2. So 2 minus 1. Well, how do I find the average of two numbers? I'm simply going to add those up and divide by 2. So I'll look at that change in the price, right? The new price minus the old price, and then divide it by the average. Well, how do I find the average of two numbers? I just add them up and divide by 2. And then we're going to do the exact same thing for that percentage change in coin demanded. We'll look at, okay, after this price change, what was the change in the coin demanded, and then divide that by the average between those two coin demanded. So I can write this out a little bit differently, right? And if you want to, instead of 2 and 1, you can kind of think about 2 here will represent the new coin demanded from the new price. And then 1 is where we're starting out. That's kind of like the old coin demanded at the old original starting price. So 1 and 2, you can think of as, if you wanted to rewrite this, you can think of 2 represents kind of the new price of coin demanded, 1 represents the old. Any questions? I know we're getting a little bit mathematical here. So any questions over anything up here so far? Okay. So you can kind of see these lining up by color coded them. So you know the change in price is just take the new price minus the old price. The average coin demanded, take the 2 quantities, add them up, divide by 2. So let's work with some actual numbers here and see if we can come up with this. So we've got what? The old price or the initial price starting out was $6. At $6, we had a coin demanded of 15 units. If we then move to our newer price, right, we lower the price by $2 and it's now 4. The resulting coin demanded goes up to 25. Right? So how do I find the elasticity of demand? Right, or the price elasticity of demand? Well, so we're going to kind of take percentage change in coin demanded, divide that by the percentage change in price. Right? But in order to compute both of these things, how do we find that percentage change? So we use that midpoint method. So we're going to look at the change in my quantity demanded divided by the average of those 2 quantity values. So that should represent that percentage change in coin demand. I do the same thing for price, right? So I'll take the new price minus the old price, divide that by the average of those 2 values. And now it's just a matter of plugging in what I was given, right? So what is the new quantity demanded? 25 minus the old quantity demanded of 15. Now, with these values, it's a little bit easier to see what would the average of these 2 quantities be. The average of 15 and 25 is 20, right? How could I mean, visually I can see, I can think about the middle number there. I've got 2 numbers, the average is just the middle value. Now I could also add those values up and divide by 2, right? 25 plus 4 or 15 is 40, divided by 2 is 20, right? So if you don't want to do this every time, if it's easy for you to if the numbers are easy enough where you can visually think about what the average is, then that you could just write that number in there, right? For example, if I was, between 50 and 100, my average would be what? 75. So sometimes it's easier to think about it. But if they're hard numbers like 3.45 and 7.29, right? How do I find the average? I add them up and divide by 2. What was our kind of new and old price? Well, our new price was 4 minus 6, divide by the average of those 2 values. Once again, I can add them up, divide by 2, or think about the average between 4 and 6 is just 5. Right. Now notice what's going to be true about the percentage change, right? This denominator here, I got a fraction over a fraction, but my denominator should represent my percentage change in price, and this numerator will represent percentage change in quantity demanded. So if I go ahead, I can do this all at once, or I could calculate them individually and then plug in just 2 values. So I can go ahead, plug in all my numbers all at once, right? I end up getting that I have this price elasticity of demand here that's negative 1.25. Right? So what does that mean? Okay. Well, first of all, before we kind of do that, in terms of this the process, right? We've got this equation, we're plugging our new old quantities of spices. You could compute them individually, and then you would have one value to plug into the numerator, one value to plug into the denominator. Whatever's kind of easiest for you to do. That next kind of homework should be up there on Canvas. And it has some problems where you're going to actually have to work through these. It gives you some actual values, but this will be the equation that you use every single time. Any questions? Sometimes you'll just be told what the percent changes in prices are, but if you're ever moving between 2 points, you might have to compute those percent changes.
So is this basically like two different, you're just like showing us the two different ways to do it?
So this is really, I mean, this is there's only one way to do it in terms of there's one equation. Well, you can break that equation down into multiple parts. So like I could find this numerator value first, then I would just have one value to plug in here. I wrote 10 over 2 would be 0.5. And I could do the denominator on its own, then have just one value to plug in down here, be negative 0.4. I want to do this all at once and enter it into my calculator. I'm really good with making sure my parentheses are in the right place, then that's fine. What I would probably suggest is try to calculate what's in that numerator first, or calculate the percentage change in quantity demanded first, then calculate what's in the denominator. That would represent my percent change in price. Well, now I just have two values to plug in here. I think that's maybe a little bit easier to break it down into parts. Does that make sense what I'm getting at there?
Kind of.
I'll show you over here.
All the numbers.
So,
You did it that way over there, and then this way with like.
Yeah, I'm just not really understanding the way that it's supposed to go. Like I was like trying to like follow along, like write it on a piece of paper.
So if we this is our equation, right? We can write it out different ways. If I go back, I can write this out. This is just kind of the way that we would read it, the way we would say it, right? The change in my quantity demanded divided by the average. Well, how do I calculate the change in the quantity demanded? I take the difference between the whole quantity. How do I find the average quantity demanded? Well, I'm just adding those two values up and dividing by 2.
Okay.
So I could do all of this first. That's going to end up being one value. Yeah. So I can show you over here. So here, I always said, depending on what way we move, it could change this. Right. So let's keep this one easy. Let's say that at $1. Let's say this might get easy. Let's say. All right, here's my quantities, I'm going to do my prices. So what I would first do is say, okay, look, I'm going to first calculate that number. I'm going to calculate my percentage change in that quantity demanded. How do I do that? I take the difference, all right? So at the newer price, it was 2, older price, it was 4. Yep, so 2 minus 4 is my change, divided by the average of these two numbers. So if I add those up, 4 plus 2 divided by 2, 6 over 2 is 3. So I get what? Negative 2/3 or negative 0.66 repeat.
Okay, and that's like the entire top part.
That's my numerator. Yep. So this is why breaking it down to steps might help. I then calculate my percentage change in price, right? My price is going from $1 to $2.
Okay.
The average would be add those two values up, divide by 2. So 3 over 2 is 1.5. 1.5 is also 2/3 there.
Okay.
And then I would have 0.66 repeated. So here I can see my elasticity of demand would actually be what? Not equilibrium, but
For 1.
it's the same values, right? So this is an easy toy example, right? It usually doesn't work out to be nice like that, right? So if I had, something like this, once I plug those values in, I'm likely going to get something. And you said 1, it should have been a little bit, I should have corrected you. One of these should be negative, one should be positive, right? It should be -1. Yeah.
Okay. That makes more sense. I think I just need to actually like write it.
See it,
out.
okay. I'm glad you stopped me. Any other questions for you? Kind of go more towards like interpreting this elasticity method. Okay, so negative 1.25, what is that really telling us, right? So we'll go to these different ranges for this elasticity. And I'll hopefully give you some support as to why this, maybe solidify this a little bit. But for now, I'm just going to tell you this is what the ranges are. So we say that demand is inelastic, right? What did we say last class? The idea of something being inelastic means that it's not very responsive, right? So if I'm thinking about something that's inelastic, that would mean that the percentage change in price, right, could be very large, but then the percentage change in quantity demanded might not change at all. That means very, very low. It was very inelastic. It didn't respond very much to that price change. So we're going to end up there having elasticity of demand that are less than 1. When I say 1, we'll say less than the absolute, the absolute value of the elasticity of demand is less than 1. So not to have to deal with negative signs, and like when I have negative signs, right, negative 50 is actually less than negative 10. So we're going to just take the absolute value of our elasticity measure. So when we're putting it in ranges of values, it makes it a little bit easier. Okay. So we're just going to kind of ignore the negative sign. We know it's always going to be negative, but to make it easier to talk about, we'll kind of take that absolute value. So if I think about this elasticity of demand, if it's less than 1, I could rewrite that like I have up here. Right? Here is how I calculate my elasticity of demand. So what has to be true, right? The algebra that I did up here is I multiply both sides by that percentage change in price. It cancels here. 1 times anything in itself. So all I'm left with is that the percentage change in quantity demanded is less than the percentage change in price. Right now, I started out with the definition. If it's inelastic, it means that this elasticity is less than 1. So if it's inelastic, it must be that the percentage change in quantity demanded is less than the percentage change in price. Right? Or think about it this way: what's the only way that my elasticity can be less than 1? Well, it's if my numerator is less than my denominator. All right, it's the only way I can get a fraction that's less than 1. If my numerator is less than my denominator, that's the only way that fraction will ever be less than 1. Yeah.
So if it's negative 1.25,
Yeah, so here, right, I said this next discussion, we'll calculate the elasticity. It's always going to be negative. Does that make it easier to talk about because with negative values, right, larger negatives are actually less, right? It's closer, it's kind of weird to think about intuitively. So generally what we do is we look at the absolute value. All the absolute value means is you drop the negative sign. So before, when we had an elasticity demand of negative 1.25, we'll treat that as 1.25, right? We'll just ignore that negative sign. So, yep.
Let's say we, like, for writing it out, like, if we were to put that answer, would we need the negative sign down?
Yeah, so if I ask you about like the elasticity of demand, I won't try to trick you like on the exam. Right, so generally the way I think maybe some of the initial homework questions, you will want to enter it in as negative because it's trying to solidify this relationship between the price and quantity demand, and they're always inverse. Right. When it comes to thinking about inelastic or elastic, we'll then take the absolute value just to make it easier to kind of write out the ranges of these values. And I think it'll make a little more sense when we talk about other elasticities as well. If we take the absolute value, we can kind of think about, it'll be the same range as when we think about the elasticity of supply. So I'm not going to try to trick you like on an exam question where I give you some negative, some positive values. If I ask you for the price elasticity of demand, you know, I'll only give you negative responses or only giving you kind of the, or I'll reference the absolute value of the elasticity of demand. Yep. So, said this is inelastic if it's less than 1. We said that being inelastic means not responsive. Well, notice what that's saying is, if it's inelastic, the percentage change in price has to be greater than how much consumers responded. The percentage change in how much people were buying was less than that percentage change in price. So I think if you think about that relationship, that is what inelastic means. That whatever change there was, the response was less than that, right? People were not responding as much as what the actual change was. I'll skip this one and come back to it. But elastic is the exact opposite. If we have elasticity, absolute value greater than 1, when it's greater than 1, the only thing that changes here is our sign, right? So when the elasticity is greater than 1, what we're really saying is that percentage change in quantity demanded, right? The only way this fraction is greater than 1 is that the numerator is greater than the denominator. So if the numerator is greater than the denominator, what that means is that whatever the percentage change in price was, consumers were responding more than that, right? They were being very responsive, right? So we see the demand is elastic when consumers are responding more than the price change in percentage terms, but I'm just trying to be concise how I'm saying it. So it's elastic demand if that elasticity is greater than 1, because that implies the percentage change in quantity demanded was greater than that initial percentage change in price.
So now my question is, does that mean the elastic value is going to be positive if it's elastic, or would it still be negative?
So notice, I'm taking the absolute value here so that we can just ignore the negatives.
Okay.
All right, so we're always dealing with positive values. So the only ranges we can see after we take the absolute value, think about it this way. So it'll be.
Bless you.
All right. So. If demand, elasticity of demand is between 0 and 1, right? Less than 1, but greater than or equal to 0, we'll say it's inelastic. It's elastic if that elasticity of demand is just greater than 1, right? Anything greater than 1 means that it had to be that people were responding more by how much they were buying, more than what that initial price change was. And then we have this kind of weird one in the middle, which is that if people are responding, what's the only way that this fraction is 1? If the numerator is exactly the same as the denominator. So if people are responding in terms of the percent of how much they're buying, exactly the same value as the percentage change in the price, they're perfectly responding to that price change. We say that is like a unit elastic demand. Now, in practice, do we see unit elastic demand very often? Usually not, right? It's one value. These are going to have decimals associated with it. Usually it's going to be, we can classify it either inelastic or elastic. But this unit elastic point does exist, right? It's just not the most common thing that we see. And it will have some uses for us down the road, which is why I'm bringing it up now. Any other questions before we move on? I think it gets a little bit more interesting. Hopefully. So, one thing we don't want to do is conflate elasticity with slope. They're not the same thing. They are related, but they are not the same thing. So what ends up being true is if I have some demand curve, right? The slope is what it is, right? It's -5 or -23, right? It's whatever that slope is, it is what it is. The elasticity of demand will change depending on where I'm at on that demand curve, right? I can kind of give you a quick, introduction as to why. Think about, let's say here, let's see, 1 and 2. And I'll go over this again once we get to something talking about revenues. But notice, if I'm moving from a price of $10 to $9 here, quantity is going up from 1 to 2. So I saw a pretty small percentage change in the price, but a really large percentage change in quantity demanded, right? Quantity demanded almost doubled. Here I was only kind of dropping the price by about the 10th, right, or 10%. So you kind of imagine there, my price change was much smaller than my percentage change in quantity demanded. So that numerator much larger than my denominator. Here, this is going to be kind of like we would have elastic portion of the demand curve. Whereas if I'm going, still dropping the price by $1 here, but I'm going from 2 to 1, well, that's a pretty large percentage decrease in the price going from $2 to $1. But the percent change in the quantity demanded isn't very large, right? 9 to 10, not exactly 10%, but roughly 10%. The percentage change in price is much larger than the percentage change in quantity demanded. So my numerator is smaller than my denominator, which means that I would be on kind of inelastic demand at this point in my demand. So the idea is the slope is always the same, but depending on where I'm at in the demand curve, the elasticity of demand could vary, right? And we'll talk a little bit more about that when we discuss revenues, but I want to kind of introduce that idea now. That the slope is the same no matter where I'm at in that demand curve, but how elastic demand is depends on where I'm at on the demand curve. In practice, you'll be computing these values. You don't have to necessarily just think about that. But yeah, they're not exactly the same.
So because it's not the slope, but like that would be like, so for instance, on this two would be on this side and then they would be here. They would line up and that's where the one.
Two.
Like I'm just looking at one of the fractions. Like
Oh, so here would be like, let's see if I'm good. So this would be something like negative 2.5 elasticity here and maybe negative 0.25 down here. Yeah. Yeah. So we're starting to think about there's going to be ranges where demand is elastic, and then there's going to be ranges where demand is inelastic. Okay, so we'll revisit this. I just want to kind of.
That makes me understand.
Okay.
With the sign, at least, now I understand, because it's like. Yeah.
Yep. So yeah, the slope is negative, the price elasticity of demand is negative. We were just taking the absolute value to make it easier to kind of talk about, right? Being less than 1, greater than 1. Now generally, so even though the elasticity does change along the demand curve, generally you can think about it, especially starting out, it'll make it easier to think about elasticity, that the steeper the curve, right? Usually we are saying that it's pretty inelastic, right? And I'll show you an example of why in just a second. And then the flatter your curve, you're thinking that's going to represent demand that is generally more elastic, right? So why is that the case? So I'll kind of show you the extremes, and hopefully this I think helps, all right? So let's say I had something that's completely inelastic. Let's start out, right? Yeah, completely inelastic. So if you were completely inelastic, and inelastic means that you're not very responsive, what that means is if I take that price at 50, and let's say the quantity demanded was, I don't know, 50 units. If I'm perfectly inelastic, when I increase the price all the way up to 100, a very large percentage change in the price, if I'm completely unresponsive, right? Inelastic means I'm not responsive. My new quantity demanded is exactly the same. If I was perfectly inelastic, means I don't respond at all to price changes. So here, if I think about that elasticity of demand being the percentage change in quantity demand over my percentage change in price, I don't even really have to do the math, because if I don't change the number of units I buy, what's my percentage change in quantity demand?
0.
0. So it doesn't even, I don't even have to calculate the percentage change in price, because 0 over anything will be 0. So a perfectly inelastic demand curve would have a price elasticity of 0. What would that look like? What would have to be at every single price, I demand the same amount. So if I graph that, all my Y values are going to be changing, but the X value will always be the same. I'll get this perfectly vertical line. Okay. And I'll never see quantity demand change at all. So my percentage change in quantity demand will always be 0. I'll always have an elasticity of 0. Okay. Questions here? This one's, I think, easier thing. So like goods, I'm starting with an extreme case. There's probably nothing that's, I guess, truly perfectly, inelastic, although you could argue a lot of like life-saving drugs are, right? If I think I'm gonna die, I don't care what the price of the drug that's gonna save me is. I'll spend my entire fortune, right? Trying to, so there, we think about maybe things like insulin, generally people are very unresponsive, but probably not perfect. There probably is a limit. But we're just starting with the extreme case and then kind of moving away.
If let's say the curve was just straight vertical, would it be 100%?
You mean horizontal?
Yeah.
Yeah, so you're jumping the gun a little. We'll get there in a little bit. But yeah, if it's completely flat, think about,
Price stays the same no matter what you do.
yeah, so if I had a perfectly flat demand curve, it's kind of weird, but there, even if I stay at the same price and I see people change how much they're buying, well, now the percentage change in price becomes zero. I wouldn't necessarily expect you to know this, but it doesn't matter what that percentage change in supply and demand it is. Anything over zero is what? Anybody ever watch Mean Girls? Right? So if you divide by zero, like in the limit, right? It's infinite, right? So limit, right? You come up with, it's not necessarily a mathematics thing I expect you to know, but the general idea is if I'm divided by zero, I actually have a truly infinite elasticity. That's the other extreme, right? The lowest I can ever see it, the most inelastic, zero, completely vertical. The most elastic, the most responsive is I keep the price the same and people buy more, right? There was no change in price and they buy more of it. So that would be like an infinite elasticity, right? Now, no one ever responds perfectly elastically, but that is to understand how to move it between the two. It's important to kind of understand the extremes. So I think I found this you guys don't know Martin, I think it's Martin Scarelli or something. But this dude like jacked up the price. I think it was HIV pills, but there was some other drug too. He was just like call him Pharma Bro.
They made something about him and Wu-Tang too.
You guys don't know about everyone's called Pharma Bro, right? So yeah, he bought like this drug and then jacked the price up, right? Because you know that if it's a drug that someone needs, they're gonna pay whatever, right? I think they did this for a while. They were like, someone bought EpiPens and like jacked the price up, and then the government kind of stepped in. But the idea is things that people need, it doesn't matter what the price is, right? You would have huge percent changes in price, and people will keep buying the same amount. I gotta have the same amount of insulin no matter what the price is. Okay, so we then move away a little bit from that to think about, well, okay, not perfectly inelastic, like that's an extreme. But what if things are just pretty elastic, right? So if we think about, perfectly inelastic, what if we're just a little inelastic, right? Well, then we would have still, not a vertical demand curve, but pretty steep still, right? And what that means is, if I'm seeing a pretty large percentage change in price here, but a pretty small percentage change in supply and demand, well, if the percentage change in supply and demand is less than 10%, and the price fell by 10, so my percentage change in supply and demand is less than the percentage change in price, numerator is smaller than my denominator, I end up with this elasticity that's less than 1. Okay? Now, it's kind of a steeper demand, right? Elasticity and steepness are not perfectly aligned. But generally, at least for now, we can start thinking about if I don't have a perfectly vertical, but pretty steep demand curve, that's going to tell me demand is pretty inelastic, right? But I can change the price by a lot, and the quantity demand won't change it very much. Questions here before we keep moving? Shouldn't be too bad. Yeah, on time. Okay. So, if we go to unit elastic demand, what should be true about the percentage change in price and the percentage change in quantity demand? For unit elasticity, yeah, if my elasticity is 1, the only way I get 1 is if those two changes are exactly the same. So visually, this would be kind of like a middle of the road slope, right? Where whatever percent change I see in price, I'm getting the exact same percentage change in coin demand. I tried to draw these, as close as I could get here. But yeah, if they had, the price fell by exactly 10%, now as a result, coin demand increased by exactly 10%, I have this unit elasticity of 1. If I then move to a slightly more flat curve, right? Well, I'll skip ahead first. We said, we already kind of alluded to this, if I have perfectly elastic, it's a horizontal curve, no percentage change in price leads to huge change in coin demand. Well, this is wild. This isn't really happening in practice, right? This would be the idea of a perfectly elastic, right? People are just crazy responsive no matter what the price is. So there we have an elasticity infinity. And then, okay, we know that in practice it won't be perfectly horizontal more than likely. But what if it starts to become just a little bit steeper, right? So it's still pretty flat, right? Well, then, even when we see it, pretty small price changes, price falls by 10%, we'd see that the coin demand is changed by more than 10%, right? So now my numerator greater than my denominator, I end up with this elasticity that's greater than 1. All the different ways of thinking about it, saying it, seeing it visually. But these are going to be kind of our ranges here. What questions before we keep moving here? So we'll next talk about some things that determine whether or not demand is elastic. And I think these will make sense, hopefully. Maybe you guys will have examples as well. So the main one is the availability of substitutes, right? So if I have more substitutes, actually, let's think about the opposite first. Let's say I had no substitutes. So the idea of like, if I've got diabetes, I need insulin, there's no substitute for it. So if there's no substitutes, what do you think is probably generally true about demand? Is it inelastic or elastic? Inelastic, right? I can't stop buying this good and go buy another. But what if I have a ton of available substitutes? So let's say I go to the store and I'm looking at, or actually 2 examples, but I like this one better, but I'll give you the second one afterwards. Let's say I go to the store and I see like 4 or 5 different brands of bottled water, like the 24 packs. And one of them is just like fairly cheaper than the other, right? Just a small percentage change in the price. What do you think happens to the coin demand of that specific brand? And I've got tons of substitutes and one of them increases their price a little bit. What do you think people are going to do? Well, bottled water is bottled water. I'm not gonna have brand loyalty, so I'm gonna stop buying that one that raised their price. So small changes in price there could lead to really huge percent changes in the coin demand of that specific brand of bottled water. Right? So when I have a lot of available substitutes, right? So I've got a lot of them, I'm very elastic, right? You change the price by a little, I might change the quantity I demand by a lot. The other example I was kind of think of this is like if I'm going to get gas. If I've got 4 gas stations on the corner, one of them increases their price a little bit, that specific gas station, they're going to lose a lot of coin demand, right? Because just right across the street, I can get it cheaper, right? Even we're talking a couple pennies. So if you have a lot of very similar substitutes, right? Gasoline is gas, I don't know. Maybe, I guess someone might think that Shell gas is different than, BP gas, but I mean, it's all the same, right? It makes your car run. So you have a very similar substitute, people are very elastic. And then on the flip side, I kind of mentioned, if I don't have substitutes, right, this is going to be where I see very inelastic demand or less elastic. I think the other examples here, I have fast food burgers, these are all the same. Really, the best way to think about it, I think, is like branding, right? When you've got different brands of bottled water, a very similar substitute, people are going to be very elastic to price changes there. And so some other examples I think that are related to this is with electricity. So this leads us to some future topics like monopoly. But if the price of electricity goes up, I might stop using as much. I might be a little more likely to make sure I turn my lights off when I leave the house. But I still have to live my life, right? I'm still probably going to watch TV. I'm still going to run, my dishwasher. I'm still going to do all these things. So I'm not going to be very responsive to changing the price of electricity. Other things, really, we're thinking about low supply. Okay? So let's say we have different sporting events. So I think we're like Super Bowl tickets, or like, whatever sports player signed jersey, or even if it's not Super Bowl tickets, you think about, maybe the Rolling Stones are coming to town. There's no substitutes for the Rolling Stones, right? And so I'm going to that, it doesn't matter what the tickets are. If I really want to go see the Rolling Stones, I'm going to buy the same number of tickets if the price is $100 or $150, right? So the fewer substitutes we have, the more inelastic people are. They'll pay, they'll buy the same quantity, no matter that we saw these kind of huge changes in price. Any questions? Or hope these examples kind of make sense. So I had found this meme at one point in time and thought it was funny. This goes back to when the replacement reps were terrible. And it said, don't worry, because the demand for NFL football is inelastic, right? It doesn't matter, people will pay. They're going to keep buying the same number of tickets no matter what we charge. So that's one determinant, right? Substitute. Right? There was no substitute for NFL games. You can kind of get away with trying to do higher price. Second thing we'll think about is the proportion of your income you're spending, right? So this one gets kind of weird. So I'll use the pack of gum example, right? Like, what are they up to now? 35 cents. It used to be like 25 cent packs. You get the 5 sticks of gum, right? When you're checking out the grocery store or whatever. So it's very, pretty low price. It's very low proportion of your income. Okay? So if they had a huge percent change in that pack of gum, let's say it went from 25 cents to 50 cents. That's a large percentage change in price. What do you think probably happens to the quantity that people purchase of that gum when they're just buying it on the whole side? Doesn't change much, right? I mean, what is another quarter of my income? So if I have items or goods that are a really small percent of my income, I might not be very responsive to huge price changes. Well, if I'm not responsive, that means that I'm inelastic, right? So if I spend a small proportion of my income on things, generally that demand for that product will be pretty inelastic. Right? So what if we do the flip side? What if I have a high proportion of my income that I spend on certain goods? So if we think about, what's a good example? So let's think about, for you guys, maybe something more like a car, right? Or you can kind of think about maybe houses, right? I'm spending a large proportion of my income on this. I'm going to make sure that I get like the best deal, right? So if I spend a large proportion of my income on something, I'm going to probably shop around a lot more. I'm not, going to just buy the first car I see. I'm going to compare prices, and there even small percent changes in price, right? I mean, if I'm talking about a car, and even $500 cheaper, if I can find the same car, that's a pretty big proportion maybe of my income, but that might be a really small percentage change in the price of that car, right? If I'm going from even 30 to 29,000, that's a small percentage change, but it's a large proportion of my income, so I'm going to be very sensitive to whether or not I buy that car with that price change. So if I'm spending a higher proportion of my income on it, I'm going to be more elastic. Right? I'm going to be a lot more responsive when I see price change. Now, in the car example, like my quantity demand of that specific car is going from like 1 to 0. I'm not probably going to buy 2 or 3 of those cars, but I'm going to go from 1 to 0, even if I saw a small percentage change in the price. So housing decisions is another really good example where people spend a high proportion of their income on this. People are very picky when it comes to whether they buy a house, right? And if they think it's even overpriced by $5,000, that might be enough to kind of make them go from buying the house quantity of 1 to not buying the house quantity of 0. But that $5,000, what you're saying, it's a high proportion of my income, right? But that is a small percentage change in the price of the house, right? $5,000, if I'm thinking about something that is going to cost me $150,000, pretty small percentage change. But I'm still really responsive. Right? So that's the idea there. And then I think I've got the pack of gum example, fountain drink, if you're like at a gas station or something like that. You can change the price by quite a bit, 50 cents to $1, and you really don't see the quantity demand change by very much. So it's just such a small percent of people's income, they just don't think about it. They're not as concerned like that. They're going to purchase the same number they were before. Any questions from the support people? So I've got one more determinant, and then we will probably wrap it up for today. What about the length of time to make a decision? So before we even get into examples or whatever, start talking about it. If I have more time to make my purchasing decision, do you think I'm more or less responsive to price changes? Which I'll phrase it on the other end, because I think that one's easier maybe to start out thinking. If I don't have any time to make my decision whether or not I'm buying this good, right? So let's say these are like convenient items, right? Like it's 100 degrees out. I need something to drink. I walk into a store, right? I don't have a lot of time to make my decision to quench my thirst. Am I going to be more or less responsive to whatever price I see of that water? Less, right? If I don't have as much time to make my decision, I'm not going to care as much about the price, which means the amount I buy will be less responsive to changes in that price. So if we have a really short amount of time to make our decision, we say we're going to be pretty unresponsive or pretty inelastic. Right? And then if I have more time, I can shop around, right? This is the idea of, I don't need, if I have a car and I'm thinking about buying a new car, I don't need that new car today. I can look for the next 6 months, right? And if you're indecisive like me, that's what you will do. Look at other dealerships, compare prices, miles per gallon, all these other features of the car. And so if you have more time to make your decision, right, then you're probably going to be quite a bit more responsive to change in the price that you see. So more time, more responsive, that means you're more elastic or demanding more elastic. So more time you have to find substitutes, adjust the prices that you see, and then less time, right? I don't have time to find other substitutes. I don't, if I need that bottle of water right now, I can't go drive a mile down the road to the next store to find it, right? So I'm just going to pay whatever the price is. I'll be very inelastic. So these are kind of our ranges. Before we go, we've got a couple more minutes here. Probably don't have to take any notes, but just to kind of give you an example of this. You can go out and generally measure these price elasticities. You can imagine, why might companies care about elasticity? Yeah, if I'm thinking on my pricing options and I know people are really, really inelastic, what do I know I can get away with as a company? Increase the price like quite a bit. Now, if it's not elastic, I have to be really careful about my prices, right? So if we look at like different goods, like matches, like you buy little wooden ones, very, very inelastic, right? I'm very sensitive to price because it's not like there's tons of brands, like I'm just gonna buy whatever it is, you change the price by 50 cents, I'm still gonna buy the same number, the number of matches I need. So we now can look at different decisions. So one of the things to here, airlines in the short run are very inelastic. Whereas if we look at airlines in the long run, right, you have more decision to shop around, look for a good flight, that actually tends to be pretty elastic, right? So different goods have different elasticities, but the same good, depending on whether I need an airline ticket in the next week versus an airline ticket in the next year, right? That can change the elasticity as well. So we start to get not just different goods that have elasticity, but kind of the decision, the time decision that people have will also influence it. You kind of see people are pretty elastic when it comes to automobiles. Education is not, anything over one is elastic, but not too far away from money. But housing decisions, private education are pretty elastic. I had some other ones here. I think I want to grab alcohol. So, we're thinking about how inelastic people are. Like people that really like whiskey and brandy and kind of they'll pay some ridiculously large prices, right? The amount they buy, it's not going to change much. Like when the Happy Man Winkle, right? People, it's like this legendary like bottle of whiskey, very limited supply. People are very unresponsive to price changes. But when you get things like with beer tends to be a little bit more elastic, right? People are going to look more for a substitute when they like a little bit more than the other. They're going to be pretty responsive to price changes. If you try to charge, if Natty Light jacks their prices up a lot, I'm probably going to switch over to like Keystone, right? It's a pretty similar substitute, and I'm going to be pretty responsive to price changes. All right, so I should wrap up today. Next class, we'll talk about revenues and how that relates to elasticity. So some more of these pricing decisions. Start to take a look at that next homework. I also put up some practice problems on the files tab on Canvas, kind of give you a good idea of what you'll see on the exam. All right, I'll see you guys on Friday.
I emailed you yesterday.
Oh, yeah. Give me one.
Out my computer.